This is a follow-up video to my first video, which was Flat Earth Width of the United States versus Australia explanation. In it, I stated that the deceivers took a flat Earth, they projected it onto a sphere, they then drew lines of longitude and latitude, and they projected that back onto a flat Earth map. And because the coordinates of longitude and latitude must match up to what they are on a flat or on this Gleason azimuthal map as they do on a sphere, it forced them to distort the flat Earth map. So I'm going to make the following points. Point number one, there is no north-south distortion on the North Polar azimuthal equidistant projection map. So this is obviously a globe. These are this is a line of longitude. These are segments of longitude. They are equal to each other. However, because this is a three-dimensional object being projected onto a two-dimensional surface, they do not appear to be equal, but they are equal. On a flat Earth, on a azimuthal map, flat Earth map, Gleason's map, they are also equal. So this is 60 degrees south, 45, 30, 15 equator, 15 north, 30 north, and each one of these segments is equal. There is no distortion north to south. Point number two, all distortion is from east to west on the North Polar azimuthal equidistant projection map, making land masses wider than they actually are. To follow that up, there's two causes of the distortion. First cause is in the third point. The distortion at the equator north is caused by the difference of the radius of the circumference of the circles of latitude of a sphere compared to a circle. So to review, this is the radius from the center to the perimeter. This is the diameter, and this is the circumference. So if we are to take 2 times pi times the radius, gives us the circumference. Okay, so on a sphere, the circumference of this circle of latitude is equal to 2 times pi times this radius here. So imagine that this is the northern hemisphere and you want to flatten it out to make it look like this. What's going to happen is this radius will go from this distance to what this distance is here, and this is a curved line, this is a longer line, so it lengthens the radius and it increases the 2 pi radius, so it increases the circumference of the circle of latitude. So you're taking this, pushing that up like that, and you're increasing the circumference of the circle of latitude, and these segments of latitude increase, and this creates an east to west distortion. Point number 4, the distortion south of the equator is caused by the difference of the radius of the circle of the radius of the circumference of the circles of latitude of a sphere compared to a circle, along with the lines of longitude converging south on a sphere versus diverging on a circle. So this is a globe, a sphere, this is the equator. When moving from the equator north, the lines of longitude converge onto the North Pole. From moving from the equator south, the lines of longitude converge onto the alleged South Pole. On a flat Earth, you can see north of the equator it's the same thing, lines of longitude converging on the center, but however, as the lines of longitude converge on the South Pole, they diverge on a flat Earth map, and this is the second cause of the distortion. So what ends up happening here is you have a situation where on a globe, the circumference of the circle of latitude at 30 degrees north is equal to the circumference of the circle of latitude at 30 degrees south. However, on a flat Earth map, you end up in a situation where obviously the circumference of the circle of latitude of 30 degrees north is much smaller than 30 degrees south. And just to give you an idea of what they did, they took imagine that this is the northern hemisphere and this is the North Pole, and you're looking down on it, and the southern hemisphere is underneath. What they did is they unfolded the southern hemisphere like this, and then they stretched out and distorted from east to west all these segments until they all made a nice circle, and that's how you ended up with a situation where Australia is about twice as wide as the United States on a Gleason's map, even though the United States is 2,800 miles wide and Australia is about 2,500 miles wide. So in my next video, I am going to go into more technical and mathematical analysis as to what is happening.